let's look at the quadrilateral family. So we can create a family tree that relates the quadrilaterals, all of its specific types, all the specific types of quadrilaterals, and then the even more specific types of those quadrilaterals. So when we see this family tree, the top one, the great-grandfather of all the quadrilaterals, is just the basic quadrilateral, right? They're all quadrilaterals. That's what we're talking about. And a quadrilateral, if you remember, is just a polygon with 4 sides. So all of these next shapes that we're going to talk about are all polygons with 4 sides. Now there's 2 that we're not going to dive into too much right now. And the first one of those would be a kite. And some kites actually look like kites. There's a little kite shape with a tail just because I wanted to draw a kite. There's also other variations as well that don't look as much like a normal kite you would see in the sky. Aside from that, we also see trapezoids. Now, if you're not familiar with a trapezoid, maybe this will jog your memory. You might be familiar with a red trapezoid block. Looked something like this. So that is one specific type of trapezoid, a regular trapezoid. There are other variations of that as well. But our main focus is really going to be the branch of quadrilaterals that begins with the parallelogram. So one specific type of quadrilateral is the parallelogram. And then we have some even more specific parallelograms that we have learned about. One of which is a parallelogram that has 4 congruent sides, which is the rhombus. And then another specific type of parallelogram was a parallelogram that had 4 right angles. And that was a rectangle. Then the rhombus and rectangle got together and they had a little baby, and that was how a square was formed. So a square is both a rhombus and a rectangle because it has 4 congruent sides and it has 4 right angles. Now, the way a family tree like this works is that you can always classify each quadrilateral by everything above it as you follow the lines. So a square is a rectangle, a square is also a parallelogram, it's also a quadrilateral. A square is also a rhombus, which is a parallelogram, which is a quadrilateral. You cannot go further down though. Every rectangle is not a square. So we can only move back up. So every square is a rectangle, every square is a rhombus, every rhombus is a parallelogram, every parallelogram is a quadrilateral. Let's get a little bit of a visual of this idea. So we have this figure, and it kind of acts like a Venn diagram for quadrilaterals. If you remember a Venn diagram, it talks about like the different overlapping things that different things have in common, right? If I draw my 2 circles, the intersection is what they have in common. That's kind of the idea of this image here. It's talking about all the properties that these different shapes have in common. So let's start with the largest one that all of these other shapes would be classified as well, and that is a parallelogram. So the parallelogram has 2 pair of opposite parallel sides and 2 pair of and 2 pair of congruent sides. So 2 pair of opposite congruent sides. It also has opposite angles that are congruent. Consecutive angles are supplementary. And its diagonals bisect each other. So those are all of the properties specific to parallelograms. And now both a rhombus, a rectangle, and a square are all types of parallelograms, so they all have those 5 properties. But they just have a few extras on their own. So let's look at the rectangle next. What is the property that makes the distinction between a parallelogram and a rectangle? What's the one extra thing that a rectangle has? A rectangle has 4 right angles. And now once we get a rectangle, so we have those 4 right angles, we also get a new property. And that new property is that its diagonals are congruent. Very cool. Now let's look at the rhombus. A rhombus is a parallelogram, so it also has these 5 purple properties, but it has its own extra ones. So to be a rhombus specifically, we need all 4 sides congruent. And then we get some extra properties as well, and that is that the diagonals are perpendicular bisectors of each other. And then we also know that these diagonals bisect the pair of opposite angles. So these are all properties that come from our very first special quadrilaterals properties page. So we know all these things to be true. Now, what about the square? A square is a parallelogram, it's a rhombus, and it's a rectangle. So the square has all the properties from above. It has every single property listed in all of the other quadrilaterals. It's got all of them. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different properties. We can say the square holds all of them.